Hi, today we are going to address the existing string functions on the new logic app data mapper. My name is Sandro Pereira, and in this video we are going to see what are the existing string functions, how we can use them inside the data mapper, and the intention of each of them. So we are going to provide input values and see what are the output of each of these operations. And if we go inside our data mapper, on the function panel, you will see a lot of categories. One of these categories is the string category, and inside that you will find a lot of operations, in this case functions, that we can use inside our data mapper to translate the data from the source system to the destination system, from code point to string to uppercase. You will find more information, more details about each of these function inside that blog article that is there on the screen. Now let's open the data mapper and let me close this one. And I already create a map for you for this exercise. I already specified the inbound and the outbound schemas. And if we open the panel, the function panel, we see that there is a string category and a lot of functions that we can use. The first one is going to be code point to string. So let's click on this one, but also because it's kind of related, let's also bring the string to code point. That's kind of the inverse of the first one. But before we map these, we need to understand what is the code point, okay? And to do that, let me bring this website, codepoint.net, that you can search for code points. Basically, code point is encoding terminology. It is a numeric value that maps to a specific character, a letter, a number, or a symbol, okay? For example, A. If we find the A, you will see that the code point representation is 65. For example, the B is 66. So that's a representation of the B. So these functions receive one input, and basically they will translate code point to a string representation or string representation, in this case a single character, to the code point representation. So let's map these from code point, and it's going to be the output 1, and in this case that is the code point, string to code point. Let's map the from string and put the outbound number 2. Now let's save it and let's test it. You see that from string is A, from code point is 66. That means that on the output we need to have the B and 65. Let's test it, and indeed we have. So all of these translation between code point to string and string to code point, it happens. So let's delete these two ones, and now the second is concat. That's a simple one. As the name mentioned, is a concatenation between strings, 2 or more strings. By default there is 2 strings, 2 inputs, but we can always add more by clicking in the add field. And in this transformation, I want to map the first name with the last name, but I don't want them together. I need a space in the middle. So in the first input is first name. In the second one, I'm going to enter custom value, going to be a space, and then the last name, and going to map this to the outbound one. Save it. It's always important to save it before you test it, otherwise the transformation is not going to be applied. Then test it, and you see that the first name is Sandro, last name Pereira, so the output is Sandro space Pereira. Good, all good, it works. So now contains, and also let's bring the ends with. So both of them receives 2 inputs. The first contains will check if the second string exists on the first string. and in the ends with, it checks if the first string ends with the second string. That's it. So let's map here the address, and let's see if the address contains Portugal. And again, both of them returns a true false value. And it ends with, again, let's map the address, and in this case, let's see if it ends with Porto. And map this to boolean number 2. So let's save it and test it. Address is Pedro's Portugal, so it contains Portugal. It needs to return a true, and then it doesn't finish with Porto, so it will return a false. So test it, and indeed true and false. So all of this works well. Now length, and that's also an easy one. It's the size of the string. So if I map the first name is Sandro, that means that he has 6 letters. So it needs to return 6. So test it, and indeed we have 6. So all good. Now we have the lowercase, and let's also bring the uppercase, because kind of they are the inverse, they are related. They only receive one input each, and the input of the lowercase, it will put all the characters in the lowercase and the uppercase in uppercase. That's it. So lowercase is going to be the first name, and the uppercase is going to be the last name. If I save it and then again test it, Sandro Pereira, the outcome is Sandro lowercase, Pereira uppercase. Awesome. Now let's delete this, and the next one is going to be regular expressions. Let's bring the 2 regular expressions on the map. One is if there is a match of a specific regular pattern, and another one is to do a replace. So the match, we are going to see, for example, country. I did a small trick on the country because I did replace the country name with a zip code for this try, and our zip code must contain 4 numbers, a slash, and 3 numbers. That's the zip code of Portuguese streets. So what I'm going to have here on the pattern is exactly that. So it has to contain 4 numbers, a slash, and then 3 numbers. And we're going to see the boolean there. Okay. Now the replace, it has 3 inputs. So let's map the city, and I'm going to put a pattern here to find all the characters A, and I'm going to replace all the A's with a P. So let's save it. Sorry, let me map these to the string. Let's save it and let's test it. So you see that city is Gaia. So I need to replace all A's with a P. And country code is, in this case, I translate that to a zip. It's not a country code, but a zip. 4415, so 4 digitals, and then a slash and 3 digitals. So all good. It's going to be a true value. And indeed, we have a true, and the outbound is replace all A's with a P, upper P. So they both work well on this case. Now we have a replace. Again, let's replace the city and replace the letter A with the letter P and come here and save it and test it. And again, we have Gaia replaced with a P. Actually, this replace behind the scenes is the same XPath function of the regular expression to replace. One use a pattern to replace and another use a string to replace, but behind the scene they are equal. Okay? Now we have starts with. And starts with is quite simple. So if you go to the address, address starts with Pedroso. It's going to check if the address starts with Pedroso and returns a true and false value or false value. So, oh, sorry, let me save it. And now if I test it, again, it starts with Pedroso, so he has to return a true value. And it's a true value that is returned. Now, substring. Substring is quite simple. We have, so let me return the address. Sorry, the address is the first input, and I want a substring from that starting position 0. So let me enter a custom value 0, and I want the first 4 digits or 4 characters, sorry, and save it, test it, and you see that I have Pedro from Pedroso, so the 4 letters starting from the first position. But I can also not specify, so let me delete these from here and put again the substring and map these again from the address, but I want everything after digital number 4. So length is optional in this case. I'm not putting the length that I want. Just from the 4 position above, I want all the substring there. And save it, test it. And you see that I remove the Pedro, but I have also Portugal. So the input is Pedroso. So I remove these 4 letters and I got this substring from here. So it works. We have 2 ways to use that. Specify a length or not specify a length. Now we have a substring after and substring before. Let's put both of them, and both of them have 2 values. So the source value, let me put the address, and I want the substring before, no, this is the after, sorry, after Pedroso. Okay. And in this case, again, the address, but I want the substring before the comma. Okay. I'm going to map it here. So I'm going to have comma space Portugal, and in the other one I'm going to have Pedroso. Test it, and you see that after we have removed the Pedroso, and before the comma we have Pedroso. So the input, you see that it respects, and the after and before works here. Now we have the trim, and this is quite simple. So I'm going to remove all the leading and ending spaces. So let's map here the description. and put the description as a string output 2. Okay, let's save it and test it. You see that description has a lot of spaces in the beginning and a lot of spaces in the end. This stream will remove these spaces and I get only this string in the middle. And you see, we got the expect result. Now, we can also use the trim left and trim right. Trim left, remove the leading spaces. So again, description, and in description I'm going to map, this to the outbound one, and on this one, description again, and I'm going to map to the outbound too, and trim right is going to remove only the end spaces, the spaces at the end of the string. So test it, and you see that left remove, but the spaces at the end stays. Left removes the right removes the end, but in the left stays. So all of these works, and that's all. So I hope you like it, and let's see us in the next upcoming video. Bye.